equals using substitution. So what I'm going to do is when I look at these two, I actually want to use this one to solve for y. And I can do so by subtracting 3x. Now in all these problems, I have always had the y being what I'm substituting for, but you can solve for an x value. And so you could have an x equals equation and then replace the x and solve for y. It just happens to be that these examples have the y almost by itself, so I've been just substituting in for y. So I'm going to use my first equation then. I'm just copying it down here since I solved for my second equation. And I'll substitute in for y again. So I have 6x minus 2. Remember, y is being replaced by the box, equals 4. What goes inside the box is a negative 3x plus 4. So I have 6x minus 2 times negative 3x plus 4 equals 4. What I now have, I have really plus the opposite here, and I'm distributing this through. So I have 6x plus 6x plus negative 8 equals 4. Combine my like terms, which gives me 12x plus negative 8 equals 4. I'm going to add 8 to both sides, and I get 12x is equal to 12. Divide by 12, and I get x is 1. Now what I need to do is take that and substitute it back in. My answer so far is x comma y, so it's 1 comma, let's figure out what y equals. So when I plug 1 in for x and I solve, I get y equals negative 3 plus 4, so y equals 1. So my answer ends up being 1, 1. Again, don't forget that you can try in those values. I'll do this one really quick. I get 6 minus 2, which is 4, and here I get 3 plus 1, which is 4. So they both work out, and I know this is the correct solution. So don't forget you can check your answer every time. Alright, in this last example, what I have is an equation that has a negative 1 for a coefficient. So it's going to require me one additional step to solve for y. So I'll subtract 2x from both sides. And then I still have my negative y equals negative 2x plus 7. So then I end up having to divide by negative 1 everywhere. So what I end up with is y equals 2x plus negative 7. So this is what my box equals. So I'm going to take my second equation, and I'm going to substitute in for y, the box. So I have copying everything else straight down except for the y. And then I'll put inside my box what y is equal to. So what this really means is that I have parentheses here. I am going to go ahead and show you that my sign changed here so you can see I'm distributing a negative through. That's one of the mistakes we'll make more than anything, so we want to make sure we do our sign change. I get negative 4x plus 14 equals 14. So when I combine my like terms here, I get 0. Those cancel out, and I get 14 equals 14. Well, this is one of my special solutions. So if I take you back to one of my prior slides, there was 3 things that could happen. We could have one solution, which we've been getting over and over. We have no solutions if we get an untrue statement, or we can have infinitely many solutions if we get a true statement. So in this answer, right here, I have a true statement. So I know that it actually has, or is the answer, infinitely many solutions. So it means I have the same line. Another way you can tell if you have the same line is if you solve both of these for y, you actually would see that you would get y equals 2x minus 7 for both of them. But having this true statement also means that there's infinitely many solutions.